In this video, I will be using the Nortec 600 and an Olympus conductivity probe to set up the instrument for measuring conductivity of different materials, as well as the liftoff corresponding to those measurements. So in order to do that, we're going to need the cal block with some known values to set the conductivity, and then we have these calibrated shims that come in this little pack from Olympus, and they show you the thickness of each one of the shims, and we use that to set up our non-conductive coating thickness or liftoff. So I'm going to turn on the tester, and this probe has a smart chip in it, so it works with the PowerLink feature of the Nortec instruments, and it's going to recognize the probe, serial number, model number. It lists it all right here, so you can confirm that the PowerLink and the chip is working correctly, and it is. So I'm going to hit continue, and I'll hit the check mark. So the system knows that we're going to be setting up for calibration based on the type of probe that I have hooked up. So it says place the probe on 30.05% IACS with no shim. Well, I don't have 30.05, I have 30.09. So you have to adjust it in the instrument. So if I try to adjust it, you notice how it's adjusting the tens and so that's, I want to adjust the hundredths here. So what you have to do is first get it close. So we'll set it to 30, and then to adjust it fine, you have to hit the check mark. And now we can take it up to 30.09. All right, and it adjusted it here. So I'm just going to take my conductivity probe, and I'm going to place it on the 30.09 IACS with no shim. And I'm just going to hit store point 1. It says now place the probe on 38.97. Well, I don't have that either. I have 60.65. So we need to adjust this to 60.65 for condition 2. 60. And for the fine, I have to do that, 60.65. All right, 60.65. So I'm going to place my probe onto that sample, no shim, and hit store 2. Now it says place probe on the 30.09% IACS with the 4 mils shim. So I have to figure out which one that is. So if I look on here, 4 mils is tan. Sometimes it's hard to find these, so I always look what's it between. So tan is between green and blue. So this is our tan because it's between the green and blue. This is 4 mils thick, or 0.004 inches. So I place that on top of my sample on the left, place the probe on, hit store 3. And now it's just telling us to move the probe over and place it on top of the shim, on top of the 60.65% IACS, and hit store. Calibration success. That's always good to see. So now I can say done. And without moving the probe, it's saying 60 point, and it's wavering a little bit, but it's close, 60%, right? And it's saying 4 mils. 4 mils is 0.004 inches. And if you look on here for the tan, it's 0.004 inches. So that's 4 mils. So right on, so far it's right on. Let's go over to the 30.09 and see what we come up with. 30% IACS, just about 4 mils. And again, this shim is 0.004 inches. Excuse me. So now let's try some different materials. This particular sample is copper. It's about 100.6. I'm not going to use any shim. All right, so it says 103%, where it's actually calibrated to 100%. But keep in mind, we calibrated on 30% and 60%, so it's going to be more accurate within these ranges. But if you go too far away from these ranges, it's not going to be quite as accurate. But let's try This one's 26.93. No, it's MSM. IACS is 46.43. 46%. That's close enough for me. Now it says I have a little bit of liftoff, but you know, there's some engraving on the back here that changes the surface a little bit, right? So maybe that has something to do. But there we're coming up with 0, so disregard. It's close though, 46 and 46. And then this one's 1.09. So again, this one's quite a bit out of the range that we calibrated at. So I don't expect it to be right on, but we'll see. 1%, I would say that's close enough for what we're doing. Now we're just going to try out some other thicknesses of non-conductive coating, in this case plastic. Let's go try something that's kind of thicker. Let's go brown. So it says that's 0.001 inches. That would be 10 mils. And the brown's between the matte and the black. So here's the brown right here. So 10 mils. We're going to try it on the 30.09% IACS. I got 29. That's close to 30. And here it says 9 mils, where the shim's actually 10 mils. So, you know, that's pretty close. Let's try the 10 mil shim on the 60.65. 58, that's pretty close to 60. Not exactly on, but, and then the mils, it's coming up with 9 mils, where this shim's 10 mils. You know, I'd say it's pretty close. I mean, what else are you going to use to test this stuff that's going to be any closer? Let's see. So I got black. What's black? This is 12. This would be 12.5 mils. So let's mix it up. Let's go over to the copper. Let's just try the copper without a shim. We're getting 100 and something. And now we'll try the 12.5 mil shim on the copper. It's going to look like that. Look at that, almost 12 mils. Conductivity dropped a little bit, but what do you expect? Okay, let's try the 12.5 mils on 1% IACS. Look like that. 1.3, 1.4% IACS and 11 mils. I'd say that's pretty close. So now you can see that it's very easy to set up the Nortec 600 to measure conductivity and liftoff, as long as you have several known samples that you can use to calibrate. And if you want to calibrate for a different range, just find different samples that have the range that you're most interested in. And of course, you always should have calibrated shims like this that are of a known value, so you can have a more accurate setup. All right, I hope you enjoyed the video. End of video.